Good morning, good afternoon, good evening to wherever you are in the world, and welcome to this webinar on spatially connected government. My name is Andy Wilson. I work for Ordnance Survey International, and my role is to help governments and organisations across the world in the benefits of spatially connected government. So my focus primarily is the Asia Pacific region, but I also work in Europe as well. So this morning we're going to just move to the next slide. This morning we're just going to talk a little bit about who we are, and then I'll move on to more about the experience of spatially connected government here in the United Kingdom. So I represent Ordnance Survey International, which is a wholly owned subsidiary of the Ordnance Survey, which of course is Britain's national mapping agency. We've been mapping Great Britain since 1791, and Ordnance Survey International provides consultancy services based on that knowledge that we've learnt from Ordnance Survey on strategy formulation, on geodesy, on geospatial data capture techniques, on product development, data policies and standards. We're also a strategic member of the Open Geospatial Consortium. We are UK government owned and completely vendor neutral. We have offices in Singapore, Dubai, Abu Dhabi, Bahrain, and we're active in over 25 countries. So I'm sure you've all seen this phenomenon. Over the last 10-15 years, maps are absolutely everywhere we look, whether it's on your smartphone, whether it's in your in-car navigation system, whether it's on your laptop. As citizens, we're getting exposed to maps nearly every single day. And I think that's been great. I think if you look at what the power of Google and Microsoft and Apple have done, they've created this absolute explosion of mapping everywhere across the world. And as citizens, we have these great experiences through our consumer experiences. And I think we have a thought about how can we then take that experience into our workplace. So we'd have a great experience with our sat-nav or our smartphone or our online experience. And we think, how can we take that into the workplace? So I think now more than ever before, big businesses, government ministers, policy officials in government are seeing the power of maps and the power of location. And this is creating a great need for spatial information across governments and big businesses across the world. And I think that's because location has become that vital component. Whether it's trying to route school buses, whether it's trying to plan for congestion and manage congestion, whether it's trying to get emergency services out to that event, whether it's trying to coordinate utilities to dig up the road all at the same time, location is absolutely that vital component. And I think that has hit home very hard over the last couple of years, particularly with government, particularly with big businesses. I think at some, in the past, maps, digital data was seen a bit of a technical operation, a bit of a back office type operation. But now more than ever before, I think geospatial systems, geospatial information systems and GIS are very much coming out of the back room and into the boardroom. And we're seeing government ministers, big businesses, more than ever before using location as an absolute fundamental component of their business solutions. So if we think about what maps were originally designed for, they were a navigation aid. I think we would see them as a way from getting from point A to point B. But I like to think now of maps, and particularly digital maps, as a meeting point for information. So you're probably all familiar with the concept of a rendezvous point, right? At an airport, you'll see a green or orange sign, and it's a place in the landscape where the ambulance crews, the fire crews, the emergency services know precisely where to meet. So I like to think of location as a rendezvous point for information. So how can you go about doing that? Well, there are many ways you could think about joining information together. You could think about using a place name, but that's probably a bit too broad. You could think about using a postcode like we do here in the UK. That's pretty good. That will get you down to about 20 addressable objects in the landscape. Or you could think about coordinates. X and Y coordinates are very good for getting to a precise place at ground level. But in the UK, we think actually the best way of developing a meeting point for information is to develop a unique spatial code for every object in the landscape. So whether that's every address or every road or every parcel of land, there is now a code that we use, which is a unique code for every object which you can actually attach your information to. So think of a map not just as a navigation device, but actually as an information integrator system. So in the UK, over many years, we've developed a system called the Unique Property Reference Number. This is a number which is unique and assigned to every property in the UK. There are now over 40 million of these unique identifiers for property in the UK. It's assigned by the local municipalities or the local authorities, and that now has become the de facto standard for government in the UK to link their information to. So if you want to connect information to a building about who lives there, which utility supplier connects their services to that building, what's the height of that building, how many floor levels does that building have, are there any vulnerable people living in that building, does the building sit on a floodplain, what's the land usage associated with that building, the UPRN becomes that unique connector. It's that way of actually bringing all that information together in a single place. And what that means is that as stakeholders and city stakeholders and decision makers, you start to build up a much better picture of that property. Instead of just having a very silo view of that property, perhaps with your own information, you can connect information from across the whole of your government to provide the best possible evidence to make the best possible decisions about that place in the landscape. And it's not just about assigning a reference to a property and leaving it at that. In the UK, we actually manage this whole process from planning stage through to construction, through to occupation, through to change of use and through to demolition. So it's a proper managed life cycle of data. So the hub of addresses we've created brings in data from the Royal Mail, which is the UK Postal Service, the Land Registry, which is the Register of Land, and the local authorities and Ordnance Survey to create this master unique data set which is relied on by government to actually underpin their address information. And it's not just identifiers at the ground level. What we've actually done is also assigned unique identifiers for every location. So that's including in high-rise buildings. So it's very useful to know exactly where these addresses are. So if you have a very tall building, maybe a 50 stories, every single unit, every single individual address within that building will have a unique identifier. And you can see the power of that, particularly if you're needing to respond quickly to that building, if, say, you're an emergency service. And of course, it's not just static information that might exist about a building or a location in the landscape. I'm sure you've all seen this phenomenon of the Internet of Things and these sensors everywhere we go now. So whether it's movement sensors capturing how many people are moving on a pavement, traffic sensors measuring the amount of cars or vehicles on the road, air quality, whatever it is that people are measuring, this is also an interesting dimension here to harness this data into your decision-making process. So think about a dashboard of information that you have, first of all, about property address and maybe roads address. So you're bringing information together from all your different parts of government to make better decisions about addressing and about road information. But then think about supplementing that with real-time information coming from sensors in the landscape. So equally, it's important to reference where your sensors are so you can pull that information in real time into your dashboards. So having a way of referencing objects in the landscape such as street lamps, bus shelters, things that you typically put sensors on is also very important. And on that basis, we're currently involved in a project in Manchester called Cityverve. We're working with Manchester City Council and a whole range of other organisations to actually look at how you then build in these sensors into the landscape. So we're surveying a 3D model of a part of Manchester, we're surveying all the street furniture, and we're therefore looking at how you can then reference those sensors in the landscape and combine that data with your other stakeholder data about property address to actually make even much better evidence to make better decisions about the landscape and your public services. And here's just a view of how that could be displayed. So here we have a 3D model. It's been overlaid with some oblique view imagery, and therefore you can click on a building in the landscape, and what you can see is you can bring all this information together in a pop-up box or your dashboard. So you're starting to combine data about the same address, whether that be the area of that address, the ownership of that property, the utility supplier for that property, how many floor levels that building has, and any other information that can be referenced to that property can be brought together in a single place to enable the optimization of public services for that particular location. And in the UK now, this notion of a unique identifier, this unique property reference number, is becoming the standard way for government to actually share its information with each other. So it doesn't just bring information together in a single place, it actually starts to bring organisations together. So we've experienced people sitting around the table for the first time who have never really debated government policy before. So, you know, emergency services, planners, environment people, for the very first time sitting down around the table and actually coming together to make better decisions around data. So whether it's about registering school places, connecting utility services, registering people to vote, dispatching emergency response vehicles to scenes, the UPRN, Unique Property Reference Number, is now the defined way of actually defining where a location is. And it's actually written in the government legislation that if you want to reference a location, the UPRN is the reference that you should use. So that's really important. If you start to settle around a standard for unique referencing, if you then start to have government legislation which supports that, it's absolutely going to deliver your optimized services and some of the economic savings that you could get from this, which we'll see a bit later on. And here's just one example of this in action. So we have in the UK a Department for Works and Pensions. Now, if you had a birth or a death in your family prior to this initiative, you would have to contact, I think it's something like over 20 different parts of government to tell them about that birth or death. So a lot of interactions, a lot of time spent in actually informing government about a birth or death. So what the Department for Works and Pensions said is we've now got this unique property reference number. It's a unique machine-readable code of 12 digits for that property. Let's use that as the way of telling everybody else across government about that birth or death at that particular address. So they developed a single web portal called Tell Us Once. It means as a citizen you go on once, you register that birth or death with the Department for Work and Pensions, and then they will instantly tell everybody else through using the machine-readable code, the UPRN, that there is a birth or death at that address. Now, the economists within Department for Works and Pensions have calculated that they reckon that over 10 years, the savings they're going to get from this project are probably around £260 million. So that's quite a significant saving. In addition, a further £68 million of savings for the families who no longer have to drive, no longer have to pick up the phone, take time off work to make those interactions. And actually, if you think about if you've had a bereavement, the last thing as a citizen you want to be doing is spending lots of time talking to government. So this is a great example where geospatial data has not only saved government money and optimized that operation, it also makes the experience for the citizens a whole lot better. Another example here where the Department for Energy and Climate Change, which is the UK agency responsible for monitoring our climate change targets, was trying to measure the effects of measures that have been introduced in the UK on our climate change targets. Now, when they were asked a question by government about the difference that some of these measures were making, they had to try and pull together data from lots of different data sets. Some from their own organisation, some from different parts of government, and some from outside of government. So as you can see on the diagram here, they had a database of where properties have made energy efficiency measures, such as insulation or solar panels. And in the bottom left, they had to combine that data with the energy supply data, so how much energy is that property using. They then had to combine that with information from the valuation office agency in the top right, which is information about that building, so attributes, area of that building. And then they had to combine that with commercial data about the value of that property from Experian in the bottom right. Now, all these different databases were based on textual addresses. So I'll give you the example of my address where this might cause a problem. My address in the UK is number 117 Bridge Road. So the Home's Energy Efficiency database may have me as number 117 Bridge Road. When I go to my utility company, they actually have me as 117A Bridge Road. When we talk to Experian, they have me as 117B Bridge Road. And when we talk to the valuation office agency, they have me as the Cottage 117 Bridge Road. So who is correct? So trying to bring that data together is almost impossible because you can't match the addresses in an accurate way. So this is where the UPRN actually becomes very powerful, because the UPRN actually is associated to all those different aliases for that address. So what the Department for Energy and Climate Change did is they created a master spine. They used the UPRN as their key, and therefore they were able to connect all this different data together very easily and therefore make the best decisions and the best evidence available to ensure that the information they was using was underpinning the climate change targets. Here's another example where the UPRN has really made a huge difference. So in the UK, if you saw an accident in the street or you spotted an emergency event, you would dial 999 and you would go through to either a police, a fire or an ambulance control room. And they would try and judge where you were by asking for your location. And more often than not, they would be able to give a rough estimate to where that location was. If you also required additional emergency services, so perhaps all three of the emergency services to attend, what they would then have to do is make a phone call to those other control rooms. That phone call typically took 4 minutes each to actually make to those other control rooms. And then, of course, it was possible for the location to be always not accurately transmitted to those other control rooms. So it was possible for 3 different emergency services to turn up at 3 slightly different locations. And that could be, you know, maybe a couple of 100 meters apart, but actually if it's one end of a street to the other, they couldn't even see each other. So vital time was lost in some of these operations. So in Wales, they conducted a trial and they decided to use the unique property reference number as a database, so this unique ID for every address, and indeed there's a unique ID for every street address as well, as a way of absolutely identifying the address and then using a millisecond data transfer operation to the other control rooms. So the first control room assigns the UPRN reference to the property, and then in milliseconds that reference is transmitted to the other control rooms. That means that all 3 emergency services turn up at the same location, at the right address, and vital time is saved. And they reckon in the Welsh trial they were saving around 18,000 hours per year. This trial has been so successful in Wales, there is now a plan to roll it out to the rest of England and Scotland. And here's another example combining pupil admission data with school transportation. So this is a school in the north of Britain, up in Withernsea in Yorkshire. They had 550 pupils using 14 buses, and by combining data about school pickup points and pupil admissions, they were able to actually reduce the number of buses they needed for this one school down to 11. That means they saved £1 million in their three-year contract with that operator. And in addition, they reduced their carbon footprint by 5.1 tonnes of CO2. So this is just one school. Think about if this was available to every school across the country. Savings are absolutely astonishing. Same goes for an operation like waste management. So waste management is an expensive frontline public service. So again, by combining data about where bins are, you could even think about deploying measures where you put smart chips into bins that then tell you how full those bins are, so you can start to optimize the collection of those bins. we've actually shown across 12 municipalities in the UK that by optimising the information about waste management, they've managed to save £3.8 million between them. They're saving between 50 and 120 tonnes of CO2 between them, cutting their fuel consumption by between 12 and 15%. And some of those local authorities showing a recycling rate doubled to 65%. So again, a great example of where information integration, geospatial data, is underpinning an absolute efficient, optimised frontline public service. I'm sure you're all familiar with the problem of roadworks and the problems that causes and the congestion that can cause. So by using the unique street reference number, so the same notion as a unique property reference number but for the street, you're able to combine information about where a utility would like to dig up the road. So in the UK, by law, a utility has to tell all the other utilities that they're going to be digging up a particular piece of road and tell the local municipality that they're digging up that piece of road. So in this system, you actually start to coordinate all the different utilities to dig up the road at the same time. That saves significant congestion challenges and saves a lot of money from the congestion outfall. And it also means that citizens can actually see where these utility roadworks are taking place. So here's an example of a website where the utilities then publish their data in a central place. This information is also available to sat-nav providers so that they can start to route you around those utility events. So again, just by using geospatial data to actually combine information about where utility plants are and where planned utility works are, you can make huge savings of money, you can avoid huge congestion challenges, and you can actually provide much better routing to your citizens. Same principles apply to our national resilience system in the UK. So we have helped develop a system for the UK government called Resilience Direct. It's a single map which allows the Prime Minister and the central security chiefs to see the same map and the same information as the police commanders on the ground, as the emergency service responders in their vehicles and on the ground. And again, using the principles of UPRN and USRN, it enables critical information to be joined together so that everybody has access to that same information in the same place and seeing that information at the same time. So we've seen a few examples of where the UK government are making some great uses of spatial data, making great use of connecting themselves together and connecting their information together. So what does this all mean in terms of savings? Well, here's just a few examples of the types of money savings that these projects are saving across the country. So it's in school buses, it's in waste management, it's in citizen services primarily. And looking at this from the big picture perspective, actually these benefits are pretty substantial. So we've done some work here in the UK to look at this. We've used some independent economic analysis. So there was an earlier piece of work that suggested that Ordnance Survey, the National Mapping Agency data underpinned around 100 billion of the British economy. But more recently, through the applications that you've just seen, where government have come together around a single data standard for unified referencing, they've come together around a single source of geospatial data from the National Mapping Agency, that last year we saw across the 15 most commonly built applications, the savings on frontline public services are around £130 million a year. But more importantly, if a majority of those frontline public services, over 75%, were to implement those applications, the savings would rise to over £500 million each year. Now that's the sort of savings that will really get the government minister's attention, and that's what we're seeing in the UK, that government ministers now absolutely understand the power of geospatial. They absolutely understand the power of unified referencing and the difference that this is making to smart and optimized public services. And I think that's the other area where spatially connected government is absolutely essential. If you think about building a smart city, what is that really? It's about optimized public services. It's about a thorough understanding of where your people live, how they travel around your city, the capacity of your networks to deliver your public services, whether it be energy, whether it be transportation or waste management, and the ability to ensure that your supply and demand meets that supply and demand on a 24 by 7 bases. And the only way you can really do that is by having a really good way of connecting information about location together in a spatial data infrastructure. Now, I heard a great quote the other day, and it was, trying to build a smart city without spatial data is like trying to industrialize a city without electricity. And I think that's so true. So I hope over the last 20 minutes or so I've shown how beneficial spatially connected government is, and the power of actually developing a standard for unified referencing, a standard for spatial data across your government can make a big difference. So it enables exchange of information between organisations that may be siloed today. It enables people and information to come together. It enables the collection of the best evidence for policy creation and optimisation of frontline public services. But I guess the most important thing is it allows your citizens to get better services, because I think that's why government's in business, right? Is to ensure their citizens are happy, to ensure their citizens are getting good public services. And that's really where all of this drives towards, is giving better citizen services. So thank you for your time. That is my contact details if anybody of you want to get in contact with me.